Okay, so today I want to talk about kind of the story of how we at Meteor came to GraphQL, or like very briefly, the kind of research that we did, and what historically what the things are that came before GraphQL. So how many of you here are familiar with Meteor, the framework? Okay, that's not a huge number. So maybe I'll explain very briefly. So Meteor is a JavaScript web application framework, and it lets you build essentially real-time applications that make it super easy to synchronize data between your clients and your servers. It also includes a build system. Some time ago, it also included basically something like React or Angular, basically a front-end framework, which we called Blaze. But the one problem that we had with Meteor, or one of the problems that we had, was that this real-time aspect of Meteor only worked with MongoDB. And that was a pretty severe restriction, because a lot of companies that we knew were interested in having this development experience that Meteor gives you, where it makes it super easy to develop apps very rapidly. They were using SQL, and they had no intention of switching over to MongoDB, mostly because they had a lot of relational queries that they were doing. So this was like about a year and a half ago, and we were thinking, well, what we really need is we need to have a query language that works across all databases, across all the backends that we could imagine, because we didn't want to go and build something for SQL and then go and build something for, if someone has a Redis backend, some service, or if someone is using a REST service somewhere, we didn't want to go and build in this kind of live query system for each of these. What we needed was a query language that worked for everything, and that's basically how we got to GraphQL. So our requirements were basically fourfold. It had to, like I already mentioned, it had to support any data source, and it had to allow joins across these data sources. So the client, the front end, should not care about where the data is coming from. It should just be able to run a query and get the data. So the server should be taking care of these joins. And also, the client should be able to declaratively fetch data. So it wouldn't have to tell the server how to fetch the data, how to find it. It should just say, like, here's the data I want, and it would arrive. And finally, and probably most importantly for Meteor, we wanted to have a language that had real-time support. And we've been doing like a little bit of research and thinking about, how are we gonna implement something like that? How are we gonna build this clean abstraction above or over any kind of backend? And when we looked around, we kind of stumbled on GraphQL, and it actually had most of the things that we really wanted and that we really cared about. And we'd made some experiences, where we'd built something that we thought was better than what the current standard was, or that was better than some competing standard. And we still think it was, but it didn't end up being the most popular thing. So when we saw GraphQL and we saw that Facebook was basically promoting it, and they'd done a really great job promoting React, we were like, okay, well, we're not going to try and compete with that, because it does 90% of the things that we wanted to do. So we basically went with GraphQL. Now, when I joined Meteor, which was about a year and a half ago, we weren't actually 100% sure. So what I did was I actually kind of looked at the other technologies that are out there, some of which you've probably heard about, which Falcor gets mentioned a lot. Another one is OData. But I also kind of went back a little bit, and I was like, how have people been doing this in the past, and how do people currently do it? And so that's kind of how this talk came together, because I was thinking, like, what could be interesting for the audience at GraphQL-Europe, where everyone is probably already pretty familiar with GraphQL. And I don't want to, explain to you how to do GraphQL queries. I could have talked about Apollo Client, but I thought it would be really interesting to kind of take a look back and see how web APIs evolved over time, or how they changed over time. And really the question I'm going to try to answer today is, was this an evolution, the step from whatever was before GraphQL to GraphQL, or is it a revolution? So is it something that's like an incremental change over what was already existing, or is it something fundamentally new, something that's going to change everything? So spoiler alert, I'll give you the answer at the very end of my talk, so you have to pay attention all the way through. All right, so basically, what problem are we trying to solve with things, like REST, with GraphQL or OData or Falcor? And I think the fundamental problem that we're trying to solve is basically transferring state between a backend and a front end, so in both directions. And the backend usually has a much larger set of states, so it has basically all the state, and the front end should be able to do operations on a subset of this state and transfer it back to the backend. Now that's like all super abstract, so throughout the talk I'm going to try to use a more concrete example, and I'm not actually going to be building anything, but I just want to make this example so you kind of have something concrete to think about. So how many of you are familiar with Medium? Okay, that's like almost everyone. It's basically a blogging platform. So on Medium, you have things like publications. So publications basically put together like blog posts from different authors. It can all be from the same author, but usually it's from different authors. You have users and you have posts. And for this talk, we don't really need to have much more. And each of these kind of resources or each of these types has a couple of attributes. So a user might have a name, might have an ID, would have followers and things like that. So these types are linked among each other. And so when we're trying to transfer state, we kind of have to transfer those links or information about those links as well. So, okay, let's kind of take a step back and see what sort of a very short history of web API technologies is. And when I did this research, I thought like, oh, this is going to go back to 1950 or something. But I actually realized that anything that's still in use today and that people are still doing is actually pretty recent. So SOAP, for example, wasn't introduced until 1999, or like formally introduced. REST came right after that, 2000. And then 2007, OData, and then 2015, GraphQL and Falcor. So really, there's not such a long history, but there's something that came before. So SOAP isn't actually really the first thing, right? It's just the application of basically remote procedure calls to the web, which is something that had been around for a very long time. So starting with SOAP. SOAP is the standard object access protocol. And like the name says, it's a protocol, and it's centered around RPC, or centered around remote procedure calls. And what that means is, instead of like asking for a specific thing, you're basically invoking functions. So you're passing some arguments to a function that is invoked remotely on a machine somewhere, and you're getting back a result. SOAP is like very much centered around XML. Like it uses XML for the transport, or not for the transport, but it's basically XML is the format in which everything is transported. And it's kind of transport agnostic, but of course usually over HTTP or SMTP, but it could be really anything. And so here's an example of a SOAP request. And this is actually a very harmless example. But as you see, it basically defines XML namespaces. It defines, so all these types that you're using here, for example, the get recent posts will be something that has to be defined in the XML schema. And what we're doing here in this example is we're actually just asking for recent posts from a publication, which happens to be the Apollo GraphQL publication. And we get a response back that's in exactly the same format. All right, so SOAP is still around, and SOAP is kind of the thing that's mostly used in enterprises internally, but it's not something that you see very much on the web. So, or maybe I can ask here, like, when's the last time that you actually programmed a web application and you were using SOAP? Or like, who did that in the last year? Okay, it's like 3 or 4 people. I have a feeling that if I ask the same question about REST, a lot more people will raise their hands. So who's used or who's built a web app, something with REST in the last year? Okay, and who has done neither? are those the people that are purely using GraphQL? I saw Dan Schaefer was raising his hand, so he's one of the lucky ones that doesn't have to deal with REST anymore. Yeah, so, all right, REST was introduced in 2000, and it was basically kind of this idea that Roy Fielding put together in his PhD thesis. And we're kind of comparing apples and oranges here because SOAP is really a protocol, and REST is more like an architectural style. So REST itself isn't a protocol. And it's just like a recommendation for how you should build applications. And we'll see in a second what kind of the principles of REST are. But the main theme is sort of that they're centered around resources. And so I mentioned these types that we had earlier in the blog, in this like Medium blog. So the resources would be things like users, posts, publications, and like if as you go on, like your application gets more complex, you'll have more resources. But a resource can also be something that like combines two things. So for example, there could be a resource that says like, oh, like follow someone. And that resource would basically represent this following relationship. So one major difference between SOAP and REST is not just that it's centered around resources, but also that it actually most often uses JSON and not XML. And I think that's actually part of the reason why so many more people today are using REST and are no longer doing SOAP anymore, because when you're programming JavaScript, it's so much easier to use JSON than to use XML. And of course, REST is kind of closely linked with HTTP. It's usually when you're calling REST resources, you're usually using one of the 4 main HTTP methods. And that's no accident, because it was actually developed kind of by Roy Fielding alongside or at the same time as he was also working on the HTTP 1.1 spec. So REST is basically a set of architectural constraints. So how many of you knew that REST was actually just a set of rules and architectural constraints? Okay, that's like a pretty good number. I always thought REST was just like something that you call your API if it uses URLs or something, but so I'm no expert here, so you should take everything that I say with a grain of salt. But so it has 5, well maybe 6 rules, but the 6th one is kind of optional. So the 5 main constraints are like client server, which means that you have a sort of this separation of responsibilities. So you have a server that provides these resources, and it's not intertwined with the client. So regardless of who the clients are, the server will kind of work the same way, and you're trying to put in this nice abstraction and a separation of responsibilities, which should make it easier to evolve your client applications and build new clients. It's stateless, which means across 2 requests, there should be no persisted state. So when you're asking for a resource and then later you're asking for it again, there should be no state kept about that connection between the client. The server shouldn't care that you were the client who made this request before. Like if you're posting a post and then later you're posting a post again, it shouldn't cause a different result if that was the same client or if it was a different client. The resources should be cacheable, or each resource should basically identify whether it's cacheable or not. And the 4th one is it's a layered system. What that means is basically that the clients shouldn't know if they're talking to an intermediate server or to a server. So if there's any caching that happens in between for cacheable resources, the client should be oblivious. So those 4 are kind of very basic, and most APIs that we call REST APIs today, they kind of fulfill that. The 5th one is like a little bit more tricky. So that's about the uniform interface, and that's basically, so it's how you identify resources. It's that each resource should be identifiable by a URL. And the second one is that when you manipulate these resources, you only do it through those representations that you get from the server. And C is that the responses that you get from the server for a request for a resource are all that you need to interpret these. So you don't need to somehow have some kind of side channel where you get some encoded information, or you don't need to go and like look up some schema somewhere to figure out what this message means. And D is kind of the last one, and the one that most REST APIs or most APIs that call themselves REST APIs kind of stumble over, which is that this hypermedia is sort of the engine of application state, which means that it's like a complicated word for saying that clients should not have to have any knowledge about these servers and these APIs encoded. They should be able to discover all the content of this API and discover like what to do with the responses that the server sends simply by hitting the endpoint. So if you hit an endpoint, for example, for most recent blog posts, you shouldn't have to know that one of the strings that is called ID that gets returned for a post, that's an ID for a post which you then can look up with the posts API. It should be such that you actually get a URL for each post. So it doesn't say ID 5 for this post, and then you have to go and you have to know that you need to hit the posts endpoint. But instead, it should give you a URL, and if you want to actually get that object, if you want to get that resource, you just hit that endpoint. So I think I don't have to do this in depth. This is basically what a request and response looks like. Now, if you kind of do REST the pure way, and the way the REST police would have you do REST, then you have one endpoint for every resource, right? And so regardless of how many different clients you have. So you have one endpoint for users, one for posts, a third one for comments or like publications. And that's really great because it gives you flexibility to develop new clients without changing the backend at all. Backend and front end is completely decoupled. So that's really what like Roy Fielding was going for in his thesis about REST, because you don't want to change the backend when you're building new clients. But the problem with that, and I'm sure all of us have experienced that, is that if you build applications in this way, like purely RESTful, you're going to have lots of round trips. And your clients are going to fetch a lot of data that they're actually not really interested in, because usually each endpoint or each resource will return like the full set of data for something. And if you don't do that, you're going to have to build a lot more endpoints, as we'll see in a second. What that does is it decouples the clients, but it also means that the clients actually get pretty complex because they have to do this whole dance of like getting data and knowing when the data is here, making these multiple round trips, and kind of keeping the loading state in the UI meaningful. So what most people end up doing is what I call restish, and that's what it doesn't have to be not RESTful, but it usually ends up being non-RESTful in some way. So what you do there is, instead of building one endpoint per resource, is you build an endpoint per view. So you get exactly the data that you need for that view in the client. So in the example of the Medium blog, I was showing you basically a list of most recent posts. So instead of doing multiple round trips to first fetch the list of posts, then fetch the posts, and then fetch the authors of the post, and then maybe fetch how many people recommended that post, you build a view exactly for that. And you just ask it for like, hey, give me the most recent posts for Apollo GraphQL. And it will return the exact data that you want. That's great because you're only doing one round trip and you get exactly what you need. But as you know, that's super inflexible because basically every time you do something new on a client, you have to build a new endpoint. Maybe your native client, doesn't show on field because there's not enough space on the screen. And do you build a new endpoint for that now, or are you okay with getting too much data and then you're overfetching again? So it's really not that easy. So what that kind of led to, and which is I think where we were in like the last couple of years, is this kind of showed the need for a standardized API layer where you could do one round trip, get just what you need, but still stay decoupled from the server. So still have servers and clients that are decoupled. And ideally, you'd also want that to be discoverable so that the clients don't actually need to know everything about this API to be able to find out about it. The technologies that I mentioned before, so it was basically SOAP, then REST, and then I mentioned OData, Falcor, and GraphQL. So the question is here, do any of these really fulfill these requirements? So OData, Falcor, or GraphQL? So let's see what things look like for OData. OData was introduced by Microsoft in 2007, and if you go to the website, it will say the best way to REST. They also have a really funny video, which I recommend you watch, because they have this jingle that goes along with it, and it sounds like they're trying to sell you medication. So when I watched it, I was thinking like, oh, at the end, they're going to say like, ask your doctor if OData is right for you. But they didn't. So OData is like very much centered around REST. It's, as they say, the best way to REST, or what they think it is. And what that basically means is that they had to take standard REST and add things to it to make sure that you could select from a certain endpoint only the fields that you wanted. So from a certain resource, you would have a standard way of saying, I want this resource, but please only give me like the blog post title. I don't need the text for this blog post. They also needed to add a way to fetch related resources. So if you're fetching the list of blog posts, well, the blog post is a related resource, so you're going to fetch that, and maybe you also want to fetch the author with the blog post. So they had this expand thing, which lets you fetch related resources. Then there's also a kind of facility for pagination, which is top and skip. They even have filtering, so you can. These are just a few. You can check for equality on basically on a field of this resource, or if it's less than, or if it starts with something. So that lets you filter on the server side, and it's basically built on top of any kind of endpoint that you have. And another one that they have is a metadata, basically, which is an endpoint by itself that you can query to actually get information. And this is very simple, very similar to kind of the GraphQL introspection query that many of us are probably familiar with. But if you look at it, so this is basically what an OData request looks like. It's just a really long string, and it just keeps going. So you'd ask for recent posts, and then you'd say like, oh, I only want the first 3, and only give me the title and the text. And then you can still filter that, and you can filter it by the organization, say Apollo GraphQL, for example. That looks really great, right? It's super useful. You think like, okay, like why isn't everybody using this? And I think a lot of people are doing things that are very similar to this. They're maybe not using OData, but they also have basically select or expand. And I've seen a lot of companies kind of roll their own, especially bigger companies, kind of roll their own OData-ish type of thing. But these things that I showed you before are actually limited, because if you look at the format of this string here, like how would you say if you wanted to expand? You're selecting recent posts, and you wanted to expand that into author. How would you specify which fields on author that you want to select? And OData doesn't actually let you do it. And another problem is with filter, for example. What if your backend actually doesn't efficiently support filtering these fields? What if it doesn't support sorting in a good way? Then the OData server actually has to implement that. And that puts a lot of burden on the person who implements these servers. And that might be part of the reason why OData hasn't really caught on outside of .NET, because there's a lot of investment that has to go into building a server. So here's an example of an OData request. It gets really interesting when you look at the response, because the response is super verbose. You have all these special OData fields that get inserted. So you'd have OData ID, even if you just ask for, here you ask for a person, I think. You get all this information, and it like links to, for example, the namespace or the schema that defines it, and then So even if you're just asking for a first name and last name, you can see that in this response, probably like 90% of the characters have nothing to do with the first name or last name. All right, so one more thing, which I found out when I was looking at this thing, is that OData actually has something that they call an OData API Explorer called XOData. And when I saw that, I was like, oh, this is kind of like graphical, right, for OData. But it really isn't, because it's very limited. So this particular view is kind of the documentation view in graphical in a way. But you're probably wondering, like, why do they have announcement in the top left? And the reason they have announcement in the top left is because XOData isn't actually free. Like, you can have a free license for like small applications, but this is actually built by a company, and they're selling it to you. So when I saw that, I was like, oh, how privileged are we that we have graphical? Because graphical is like 100 times better. and it's free. So the next one that often gets mentioned is Falcor. And in Falcor, all data is modeled as a JSON object with references. Oh, maybe I should ask, like, who's heard about Falcor? Okay, that's like a good number of people. So Falcor basically follows the idea that all your data, or you can think of all your data as a kind of an object. It's JSON, but with references. And whether that lives on your server or on your client, you really shouldn't care about on the client. So you should be able to ask for some part of that JSON object without knowing if it's on the client or on the server. That makes it super simple to write client code because everything basically gets resolved asynchronously. And so it becomes much simpler because you don't have to worry about where exactly the data is. You can write routes on the server to determine how the data is fetched. So you can piece this JSON object together from different resources. It doesn't have to live in memory. And all the data is basically treated as a graph on the client and not a tree. And this is very different from GraphQL because in GraphQL, the data on the client is basically a tree. And if you want to treat it as a graph, you have to do some additional transformation. Falcor is really easy to learn and it's really easy to use. And I think that's one of its biggest advantages. But the disadvantage is that it doesn't have a type system and you cannot provide arguments. So you cannot give arguments. You can like select a range from an array, but you couldn't provide arguments like saying, I want only the posts that start with the letter A or whose title starts with the letter A. So here's an example of what a Falcor query would look like. So here we're asking for users, or user number, or user with ID 5, and we're asking for the name and the age. And that's basically what we get back. Now, finally, GraphQL. I don't think I have to go into too much depth with GraphQL. We've all seen GraphQL queries. Are you happy to finally see GraphQL? Yeah. So GraphQL is a really easy to use query language. You get exactly what you need. It has a type system, it has advanced tooling, and it has this resolver runtime, which makes it much, much, much easier to build servers with GraphQL than with OData, for example. Yeah, I might be a little bit biased, but we'll get to that later. But so an interesting question to ask, is GraphQL RESTful? So the first four are actually really easy to kind of take care of because that's usually the case for any system on the internet. But when it comes to a uniform interface, actually it turns out like GraphQL, at least in its basic form, doesn't have the property that once you fetch data, you can easily know like where to fetch more of that data. Once you've fetched a tree, if you don't have some kind of encoded information about the identity of these objects, you cannot expand on those. You cannot fetch more. And what that also means is that not all the information that you need is included in the response. So hypermedia as the engine of application state isn't really given. But what if you take GraphQL and you add the node interface? So it's something that was popularized by Relay, I think. So if you specify the node interface, then every object or resource needs to have a unique ID. So this needs to be unique across your application. And every resource can be retrieved given its ID. So what that would look like is your server would expose basically a root query type for node. And if you specify that, you can fetch a post here, for example, given just the ID. And if you do that, you can actually check all the boxes for REST. And you can make your GraphQL server be a RESTful server. So maybe we should really say, instead of saying that GraphQL can replace REST, we should say GraphQL is the best way to REST. And get into an argument with Microsoft. So okay, so you've seen all this different technologies. And of course, the winner is GraphQL, surprise. I'm only saying that because I want to get out of this room alive. But no, I really do think that. And I'm actually out of time, so I'll go like very quickly why I think GraphQL is winning. And I think the reason is that the query language is really straightforward. It has absolutely amazing tooling. So I'm thinking about things like graphical or also Launchpad, which you should check out if you haven't yet. And it has a much stronger developer story than Falcor or OData. It's much easier to adopt. And it's easier to adopt than OData, and it takes you much further than Falcor. It has a really strong community, as we kind of see today. It's like not common that a 2-year-old technology would have a conference in Europe with like 300 attendees. And it has a really good incremental adoption story. So let's get to the question. Is it an evolution or a revolution? So technically, I would argue that GraphQL is actually just the next step in the evolution. Because if you look at the things that came before, if you look at REST, and then particularly if you look at OData, a lot of the concepts that GraphQL has, they were present before, and they're kind of borrowed and put together. And I think the main innovation was actually the resolvers, at least from my perspective. So technically, GraphQL is really an evolution. But sometimes, when you improve something by a little bit, you actually get to a kind of tipping point. And I think that's really where we got to with GraphQL, because it made it so much easier to specify exactly which data you want. You can do that with OData, but with GraphQL, it's just so much easier. It's so much more straightforward. It has much better tooling. And what that leads to is this kind of virtuous cycle where more and more people become interested in this technology and start contributing tools and start improving the core libraries. And really, that's why I think socially, GraphQL is a revolution. And I will skip to the end. If you're interested in those slides, I will upload them. But they're basically slides. Oh, no, wait. I have to go back here. They're basically slides that should help you kind of sell your colleagues and sell your friends on GraphQL. So if you want to join the revolution, which I think all of you have, or convince your friends to join the revolution, you should join one of the Slack communities, or all of them. So GraphQL, GraphQL, Apollo, I think Reindex still exists, maybe. And contribute to GraphQL and Apollo on GitHub. Tweet about it. Show Launchpad to a colleague, or like check out Launchpad yourself. I'm just really excited about Launchpad right now. And give a talk about GraphQL. If you want, feel free to take any part of my slides or slides from other presentations. And it would be really cool if you did the same and kind of provided your slides to the community to talk about it, or organize a GraphQL meetup or a conference. All right, that's all I have to say about that.
Okay, thank you. I forgot to mention I work for Microsoft, so we're now going to fight about the best way to rest. I'm going to speak at the OData conference and claim that OData is still the best way to rest. You want to say something?
Actually, I looked that up before I gave my talk, and I don't think there's an OData conference, but maybe I'm just not.
You ruined my joke. Okay, moving right along.